Hello everyone. Today I'm going to be showing you how we can import isoelectric point and molecular weight markers into our 2D images to help identify the isoelectric point and the molecular weight of some of our spots of interest. Hello everyone. So today I'm going to be showing you how we can import some of the information from our experiment that is contained within our image, if it has been imaged, to assign the isoelectric point, aka the PI, and the molecular weight of some of the proteins that have formed our spots in our image. So to do this, we do this in the spot picking stage of the SameSpots workflow, where we can export picking lists to automated robots for excision of proteins from a gel, or we can export a manual picking list for manual picking in the lab. So we come through to this mode and we come through to the bottom left corner of the application, where we've got a button that says PI and molecular weight calibration. Left clicking that will bring up whatever image you had selected in the previous step. I only have one image in this demonstration, so it's just opened the only image that it has access to immediately. As you can see, this image has an IPG strip across the top that runs from a pH of 3 to a pH of 10. Unfortunately, it doesn't have a molecular weight ladder in this experiment. However, I will show you the process if you did have one within your experiment to assigning where those molecular weight markers are and the values associated with those. So as you can see at the minute, I've not done any kind of spot filtering, so I've got literally every area of interest has been marked as a spot in this image. And we've got no kind of experimental information in our table of results on the left hand side because we've not given it any information to work off at this point. So the first step would be to import your pH values, your PI values, based on the IPG strip that you've used. Now this is a pH 3 to 10 strip, so what I need to do is add a PI marker, and I do this by right clicking and give it a value of 3 on the left hand side. Come to the other end of the strip, right click, add PI marker, give that a pH of 10. So I can left click and drag to move these around if I think I've placed them in the wrong area, or I can right click them and select delete to delete them. Now, the model that SameSpots uses to interpolate values between these 2 points is a linear model. So what it does is it takes the distance between number 3 and number 10 in pixels, and then it assumes that across this range there is a linear increase. So it takes the pH of 7, so it takes 7, divides it by the number of pixels that it detects between these 2 lines, and gives each one a very small percentage of that 7. So when you move across the image, you get your pH change of 7, so you go from 3 to 10. Each pixel has the same value as an increase. And this is the only mode that it can work on. It can only do linear changes between the two, which is what occurs in the vast majority, if not all, IPG strips are based on a linear increase in pH. Now, as you can see, once I've added these 2 values, and you can add as many as you want, you're not limited to just 2. However, you can get away with just 2. Now, once I've added this piece of information, the isoelectric point, the focusing point, the pH at which the proteins have no net charge in either direction, positive or negative, you can start to see that the table of results is being filled in automatically. So you can start to see that when we left click our spots, we're starting to get a PI value for this spot, which is one part of the puzzle towards the potential identity of the protein that this spot is made of. The second piece of information we need to import is the molecular weight. Now, we do this by using the same mechanism. We right click on the image, left click on add molecular weight marker, and we tell it what our marker is at that particular band, point, spot. So say if I had 10,000 here as part of my molecular weight ladder, and then say 5,000 was here, etc. So now we're starting to give it the information for molecular weight. So if I come to this spot, you can see because this spot is between the 10,000 and the 5,000, it's now given it a molecular weight as well. So now we're even closer to identifying what our spots, what our proteins are. Now again, the same as SameSpots presumes and can only interpolate a linear correlation between the 2 different ends of your IPG strip, your pH strip. It will also only apply a linear model, a linear interpolation model between the 2 or 4 or 5 or 6 points in your molecular weight ladder. So again, it presumes that there's a linear change between these 2 points in molecular weight, and it will calculate your spots, isoelectric point and molecular weight from that information that you've given it. So this is how you would calibrate your gel to have this particular information, and we can go one step further within SameSpots, and I think I'm going to make a separate video on this because it's a little complicated, but we can integrate SameSpots with a list of proteins, or a list of proteins that you've developed and created yourself, or one that you've downloaded from a database like MASCOT, and we can import those into our project, and it will, based off the information in that database and the PI and the molecular weight information that you've now got from your image, it will try and identify what it thinks the proteins are that your spots are. So it will try and, you can see here in the table, it will try and give you the protein accession number and a description of the protein. Thanks for watching, and if you'd like to trial a copy of SameSpots within your lab to see how it can help empower your 2D proteomic analysis, please check out the links in the description below.